Hi, in this session, let's quickly recap what we have seen in work and energy. I won't be going into the details. We will look at the key things that we need to know when we go to write the exam. Work done by a force, W equals force into distance, F into S. Force, the unit of force is Newton, and the unit of the displacement or the distance moved is meter. So work done, the unit would be Newton meter, and 1 Newton meter equals 1 joule. So 1 joule of work is said to be done when 1 Newton force is applied on a body and makes it move 1 meter in the direction of the force. Now the key thing to note is the direction of the movement should be in the direction of the force. So W is equal to force into displacement or distance. So the important thing to note there is the distance of the direction of the force and the displacement. The displacement should either be in this direction or in this direction. It should be in the line of the force. Okay. Now, there can be certain cases where I have a body and there's a force which is at a certain angle theta. So, if the body moves a distance s, what would be the work done? So, here the work done is equal to F cos theta into s, because the component of the force which is in the direction of displacement would be F cos theta. If theta equals 0, then cos theta is equal to 1. If theta equals 90, cos theta or cos 90 would be 0. That means if the direction of motion is perpendicular to the direction of the force, then the work done is said to be 0. The example there, the one that we see often is, there's a coolie here and he's carrying a load from point A to point B. So now, what is the work done by the force of gravity? The force of gravity is pulling this down, but the direction in which it has moved is towards the right. So the angle between the direction and the force is 90 degree. So here the work done equals 0. Something similar is what you would see when you have the sun here and the planets. So the planet goes around the sun. Now it is being pulled inward by the force of gravity. The reason why it goes around is because of the force of gravity. But at any point, if you were to look at what is the direction of the displacement, it is here. So the angle between the force and the direction of displacement is 90 degree. So the work done in this case would also be 0. So if you look at it, the work done can be positive or negative, or it can be 0. When the force and the displacement are in the same direction, then theta equals 0 and work done would be positive. If force is in one direction and the displacement is in another, then theta is equal to 180 degree and cos theta would be negative 1 and the work would also be negative. So we have positive work, we have negative work, and we have 0 work. And 0 work, as you know, is when the force and the displacement are at right angles to each other. Now, what is the unit of work? The unit of work is joules. 1 joule equals 1 Newton meter. So 1 joule can be defined as the work done on an object if a force of 1 Newton acting on it causes a displacement of 1 meter in the direction of the force. So let's look at this negative work. When does negative work happen? A particular example that you can always see is, suppose I have a car, and when you put on the brakes, the car the car still is going forward, okay, but the force that you have applied is in the other direction. So the force and the displacement are in opposite directions, and here we would say negative work is done. Another point is when you throw a ball up. So here what is happening is the ball goes up, so the displacement is in this direction, whereas the force of gravity is pulling it down. So, so here negative work is getting done. In the other case, if a ball is coming down, so the displacement is also downwards, and the force of gravity is also downwards, and therefore the work done here is positive work. Now, what would be the next important thing? The next important thing is the law of conservation of energy. We have discussed it in another video, but to quickly recap, law of conservation of energy basically states that the energy, total energy, remains the same. Energy can neither be created nor destroyed. It is just converted from one form to another. So we also discussed about the kinetic energy and potential energy. The kinetic energy is the energy in a body by virtue of its motion. So the formula for that is half mv squared. And the potential energy of a body is the energy of a body by virtue of its position or change in shape. So this, if you look at gravitational potential energy, the gravitational potential energy is mgh, where m stands for mass, g for the acceleration due to gravity, and h is the height from the ground. So that is the potential energy. So the total energy at any position would be equal to the potential energy plus the kinetic energy. This remains the same. Now, next we have another term known as power. Power is nothing but the rate of doing work or work by time. So the unit for this would be work is in joule, time is in seconds. So power is joule per second, or it has also been given the name as watt. But watt is a very small value. In case of electricity, we talk about kilowatts, and the amount of energy consumed is referred to as in units. So what is 1 unit in electrical parlance? So 1 unit is defined as 1 kilowatt hour. So 1 kilowatt hour, if I were to convert it to watt second, it would be 1 into 1000. So 1 kilowatt is 1000 watts, and the 1 hour is 60 into 60 seconds. So it is 3.6 into 10 power 6 watt second, or 3.6 into 10 power 6. I can also say it as joules. So the commercial unit of energy is given in kilowatt hour. So with these few key things, I think we'll be able to do most of the problems that are coming in this lesson. If you still have any doubts that you feel because due to which you cannot answer any of the questions in the books, please message me.